Okay, so this video is about work. So work is a type of energy. Really, it's a transfer of energy. It's a transfer of mechanical energy either into or out of a system or on an object by some outside force or forces. So let's take the system to be my car, which has just run out of gas, unfortunately, on the way to my destination. It used to have a tank full of chemical energy that it could convert into kinetic energy to get where I'm going, but now it doesn't anymore. So if this car's ever going to get going again, it's going to have to get some kinetic energy from somewhere. Luckily, I ate my Wheaties this morning. So I got a push. So I dig deep and I use the energy from the Wheaties to exert a mighty 1200 Newton push on my car. And as a result, I get that car to move from point A to point B. And that distance from point A to point B, right, that's the displacement. So the amount of work done, the amount of energy transferred to the car by me from my push, right, comes from the force that I push with. The bigger the force, the more work that's going to get done, times the displacement, right? The farther you've gone, the more work you've gotten done. As for this cosine theta, the angle there, we'll come back to that one in a second. In my example, the work I did pushing the car was positive. You can tell it was positive because the force, right, the arrow to the right, and the displacement are in the same direction. So that means positive work. I put energy into the system. Let's see what an example of negative work looks like. So, from time to time, I have to go and walk my sister's dog. And that's exactly what he looks like. The problem is this dog is overly enthusiastic, and if I want to keep him from running down the street, I have to exert a force in the other direction to the way that he's moving. So even though I'm pulling back on him, I'm pulling him to the left, he still ends up going where he wants to go. He moves to the right. So his displacement is to the right. So you can tell that this is negative work, because the force, which points to the left, is in the opposite direction to the displacement, which points to the right. You can see the angle between them, right? That angle there is 180 degrees, and that's going to be important later. You can also tell I did negative work because I took energy out of the system, right? My pulling backwards on the dog caused him to go slower than he would otherwise have been going, right? I removed energy from the system. That's negative work. Now, sometimes a force will do no work at all on a system. So as an example, I like to ride in elevators. So let's say when I'm riding in this elevator, I'm exerting a horizontal push against the walls of the elevator. And as I'm pushing to the right, the elevator is going to do what elevators do, and it starts to move upwards. So in this case, we have a displacement that's upwards, and we had a force that was to the right. So there's no work done. Work equals 0, because the force, which is to the right, is perpendicular to the displacement, which is upwards. So that force has nothing to do with the vertical motion of the elevator. It doesn't add or take away any energy from the system. So now we're ready to understand this cosine theta part of the work equation. So we saw that when the force was in the same direction as the displacement, the work done was positive, right? We put energy into the system in that case. Now the angle between the force and the displacement is 0, and the cosine of 0 is 1. We end up with a positive number for work. Next we saw that when the force was in a direction opposite to the displacement, negative work was done because we took energy out of the system. So the angle there, though, between the force and the displacement is 180 degrees, and the cosine of 180 degrees is -1, so we end up with a negative number for work. And in the last example we saw, we had a force to the right, but a displacement upwards, so those two are perpendicular to each other. No work gets done there, right? That force doesn't add any energy into the system or take any away. the angle between the force and the displacement there is 90 degrees. Of course, the cosine of 90 degrees is 0. You can check that on your calculator. So when you plug that in, you get 0 work done from your equation, since that force isn't adding any energy or taking any energy away from the system.